So as hopefully you guys looked at last night and saw, it's just a pretty basic problem for the first two. Create your scatter plot, find the least squares regression line. Your calculator can do that for you. And of course, you can show it in different ways. But anyways, C and D. So for part C, assume that all conditions for inference are met, indicate the hypotheses appropriate to test whether there's a linear relationship. So just in general, what are the hypotheses we use for linear regression? Maybe just start with the null.
The slope is 0.
All right. And specifically the population slope, so I'll put beta is 0. We're saying there's no relation. Now our alternate could be that beta is, well, in this case, maybe let's just answer it for this one specifically. What might you write your alternative hypothesis as?
Beta not equal to 0.
I think not equal is the best assumption here. If it specifically asked you to test that your slope was greater than 0, then of course we could do that. Or if it said you suspect there's a positive relationship between the, what is it called? The dial setting and the output length. You suspect there's a positive relationship. Well, then you're testing that you have a positive slope because it's positive. As one goes up, the other goes up as well. But whatever the case, it's maybe a good idea just to use not equal to 0 because it's a more conservative estimate. So whatever you get is your p-value, and this is just general for this because it's a two-tailed test. Because of that, we are going to double our p-value. All right, pretty straightforward. And not much to that. I don't know if we need to say more about it. But the next one, it actually gives us the test statistic. It is possible you could have an FRQ where they give you the printout and they want you to come up with the test statistic and run the full inference test. Here, they didn't even expect that of you. They gave you the test statistic, so we only need to worry about the very last part. So essentially, a test statistic of 9.018 is saying if we had a distribution, I'm drawing this tail way over here. That's not a right skew. That's just showing this going way over to the right. So one standard deviation is about right there. 2, 3, 4, 5, 6, 7, 8, 9. So I'll just essentially say that that's where our t value is. So we want to find this area right here. Is this statistically significant? Do we have convincing evidence? And of course, we could find this. This would be a TCDF calculation. And the one thing that we need to be aware of is, okay, so we want to go in and figure out what our p-value is. And we could probably, even without doing calculations, and sometimes it says don't even use calculations. So just answer it conceptually. We know that because this is so many standard errors away from the null mean, that this is basically, there's no way this was by chance, and there's definitely an association between these two. So we could feel confident just conceptually already. But if we wanted to be more thorough and give the p-value, we could do a TCDF. Now remember, we had 8 in our 8 objects or whatever in our sample size. So our degrees of freedom for linear inference or linear regression inference is n minus 2. So now we've got 8 minus 2, so our degrees of freedom is 6. So I want to use 6 degrees of freedom. I can use TCDF on the calculator. And I'm going to go from 9.018 to positive infinity with 6 degrees of freedom. And I get a very low number. This is 5.205 times 10 to the negative 5th. But of course, we are doing a two-tailed test, so we want to double that. So I'm going to say times 2, which gives me 1.041 times 10 to the negative 4th. So there is my p-value. So, I mean, at this point, you could write a sentence, because our p-value is less than the significance level or any reasonable significance level. It doesn't even tell us what significance level to use. Because below any reasonable significance level, we have convincing evidence that there is an association between these two variables. And what else was I going to say with that? Oh yeah, we reject the null hypothesis. There we go. Pretty straightforward. If you have more questions on that FRQ, of course, we can look at that later. Let me change our focus over to the presentation. And there's not much for today. Let me present. So here is the answer key. I'm going to come back to it just so I can say real quick, turn in anything you need for credit. I need to really reinforce that. Tonight is the deadline. Okay, here's the answer key for the practice test I asked you guys to take. So I'm going to leave this up here. And at this point, you are free. If you don't have any questions about anything, then you're good to go. But if you have questions on the practice test or anything else that you need to get prepared for your final tomorrow, then you can stick around. So have a great day.